Now let us do something more more complicated. So we'll now size or design a cooling water network system.
Cooling water network. Great.
So cooling water network means you got a cooling tower. Right? So from the bottom cooling tower basin, we'll take the water suction to the pumps, cooling water supply pumps, and those pumps will send this water to different heat exchangers in the plant. The objective of having this cooling water is it will take some heat out of process fluid. Like say benzene is there as a process fluid, you want to cool it down from 90 degree to 60 degrees C. So that cooling will happen because of cooling water, and in turn the cooling water temperature will increase from say 30 degrees C inlet, it will go to say 40 degrees C, and that 40 degrees C water will be sent to the top of the cooling tower, and it will be sprayed down. And on the top of the cooling tower there will be a fan. Okay, mostly ID fan will be there, induced draft fan. It will suck the air, ambient air from the bottom. So there will be counter current. The water droplets will fall from top to bottom, and air will travel from bottom to top. So while this this water is going down, air is coming up. So there will be mass transfer. Some water will get evaporated, and because of that, that heat will be taken up by for the evaporation, and the water in turn will get cooled, and the moist air will go out of the cooling tower because of the fan, right? And the water when it drops down, it will be like say 30 degrees. So accordingly, the cooling tower vendor will design it, and again the 30 degrees C water will be sent to the cooling water supply pumps, and the same cycle will get repeated, right? So there is another picture of this. In this case, we have got 3 cooling towers, city 1, 2, 3. There are 2 pumps. So normally it will be one running, one standby, right? And this water from the cooling water supply pumps is sent to this total 11 exchanges in this particular diagram, and the cooling water return will be connected in the common header, which is called as cooling water return header, and it will be sent to the cooling tower top, and the same procedure or same cycle will get repeated. So there will be some water loss in the cooling tower, or there will be one the water will be purged out or blown out from the system to maintain the salt concentration, and this cooling water makeup line will be added. So if you see this cooling tower basin is there's like a small tank to store the water. As the liquid level goes low or low, that time this level transmitter will give signal to LIC, and accordingly this cooling water makeup valve will get open, and it will fill it till the required level. Now if you consider this, let's say water tank or cooling water tank, what is the pressure at which it is operating? It is 0 bar gauge. Yes. This cooling tower basin, it is open to atmosphere, right?
Yes. Yeah.
And when this cooling water return header, this line, when it gets spread, okay, onto the top of the cooling tower, what is the pressure at this particular point?
Atmospheric.
It will be again 1 atmosphere or 0 bar gauge pressure, right? So we know that these 2 boundaries are with known pressure, which is 0 bar gauge or 1 atmosphere, right? So we are going to model this system. If you see, we have got this tank number 1, which is nothing but cooling tower basin. It goes to 2 pumps, right? One running, one standby. Those are cooling water supply pumps, and this sends water to these 3 exchanges, right? There are 3 exchanges here, and the temperature change, it says 10 degrees C. So an inlet is 15 degrees C here, and the outlet is 25 degrees C. So this 10 degrees C temperature rise is happening across the exchange, right? We are going to model this. So what information we require? What items do you see here? So 2 tanks, 2 pumps, and 3 exchangers. Okay, let us draw this. Earlier file, you can close it. Okay, so on the top, if you see, there is this the view default is 80%. So I would change it to 60% so that we can fit more items in this flow sheet. So the first one is the known or assigned pressure boundary. So I'll put it here, and somewhere here, not at the bottom but little up, that is the second tank, which is cooling tower basin. So this boundary work is done. Then comes the pump. Pumps are available in booster. In booster, we'll go for the first one, so centrifugal pump. So somewhere here, I'll put one pump, and here another pump. So it looks little bit symmetrical. And heat exchanger is available on the last, right? And I'll use shell and tube. I'll click here. This is the first one, the second, and this will be the third one. All right. Okay, so please draw this. Once it is done, please write done in the chat box. Please save this file. All the problems we are going to solve today are already available in the session 11 FluidFlow folder as solved example from the presentation.
I'm trying to save, it's not saving. It's terrible.
Did you give file name?
I'm going to file. I click file. Okay, maybe because you have control, I don't know. I click here. Yes. So it's not saving. Maybe you have control, that's why.
I don't have control. I'm sharing my screen, sir.
Oh, this is your screen?
Yes.
Oh, sorry. No wonder.
All right. So once it is done, please write done. If you need help, please ask. So let us proceed. Now in the problem statement, in the pump suction side, how many pipe segments you see? You see this one, then 2, then 3, then 4, and 5. Right? So we need to draw 5 pipe segments. So I'll go to pipe. I'll use steel pipe, first one. First, listen, just watch what I'm doing. Then you can do the same. Now from the bottom tank, I'll start and go to, let's say, 3 dots on the right. Right? So you can see there is one open pipe. So from that open pipe, I'll draw one line up. You notice that open pipe has become a bend. Again, from the other open pipe, I'll draw one line to the pump, and that open pipe also became a bend. Then from this bend, I'll draw one line down. That bend has become now a T. Similarly, open pipe to the pump. All right, so how many pipe segments? 1, 2, 3, 4, and 5. And how many bends? 1 and 2. And how many T? 1. Okay, please complete this. Once it is completed, please type C. In the pump discharge side also, we'll have the mirror image. So from the pump, I'll start, click from the other pump, another line, click from open pipe to, then from open pipe to open pipe will become a bend. From bend, I'll go to the right, which will be in the same column as the first exchanger. Okay, once it is done, please type done. Now these pipes, 5 plus 5, 10, these pipes are in the pump house, cooling water pump house. Now this cooling water has to be taken to the different units, okay, different locations in the plant. So from this pipe, it will become a header. So from 14, this one, I'll draw one line up. Okay, from 15, I'll go all the way to the right. And then from this header, this is called as cooling water supply header, we'll give one tapping to the first exchanger. Then from the pipe, you give tapping to the second exchanger, and from this open pipe, another tapping to the third exchanger. So far, this is called as cooling water supply header. Okay, please complete this. Mr. Mark,
Yeah.
how are you doing?
Yeah, I'm on it.
Okay.
I'm sorry.
Then again from the exchanger, I'll draw one line up. From second exchanger also one line up. Then third also one line up. And from this open pipe to open pipe. From this bend to the open pipe. And from this bend again to the cooling tower top. Alright, so this is the complete model.